Hi, I'm Sujan Shetty, the team coordinator. Meet my team Srinath Reddy, Kaushik Chaudhary, and Naren.
So the demonstration setup basically consists of a water tank and a pipeline attached to it. This pipeline has solenoid valve which is connected to it, which in turn is connected to the microcontroller. Finally, we have a wash basin at the other end of the pipe. So let us consider a basic user scenario where we have a person walking towards the water utility setup. When the user touches the doorknob, he will be in contact with a temperature sensor which leads to a sudden change in temperature which is detected by the controller. An ultrasonic sensor would detect the user's presence and drive the solenoid valve from closed state to open state. As you can see, the user forgets to close the tap and leaves it running. But the ultrasonic sensor at the top detects his absence and drives the solenoid valve back to the closed state, hence saving the water.
The circuit connection goes like this, where MSP430 provided by Texas Instruments acts like a core of our system, in which for which temperature sensor, ultrasonic sensor, as well as solenoid valve for driving are connected. Pin number A0 is connected to temperature sensor. Then from MSP430, pin number A0 goes to temperature sensor for getting human temperature value, and pin number 2.2 is connected to ultrasonic sensor for making sense of the human presence. At last, pin number 2.4 is connected to driver circuit, in turn driving the solenoid valve. This is DRV101 circuit provided by Texas Instrument. Here we are using for driving solenoid valve. The input of this pin is given from MSP430 through pin number 2.4. Potential difference of 9 volts is applied throughout this circuit. At last, potential difference of 12 volts is given throughout the solenoid valve.
Let us consider a simple use case where we have a residential building with two floors having common water supply with an overhead tank. The main water connection is forked between the two floors. Consider a scenario before the implementation where a user comes in and starts using the water utilities. Later, the user forgets to turn off one of the water utilities after being used. Now, over the course of time, water keeps on draining due to the negligence of the user, in turn draining the main water tank, leaving both the floors without water. Now consider a scenario after the implementation of our central locking system. Here once again, user comes in and starts using water utilities. But this time, the human presence near the particular water utilities will be sensed by our ultrasonic sensors, which will in turn open the central valve for that particular floor. Here once again, the user will leave the water utility open after usage and will exit the premises. The ultrasonic sensor will once again detect the absence of the user and will shut off the central monitoring valve for that particular floor. This simple and effective mechanism will drastically reduce the water wastage over time.